Hey guys, so this is the bonus round tutorial, and we're going to be going over a pretty complex, conceptually at least, shader to build. And the reason is Redshift does not currently have a thin film utility node or shader, and so this can be a little problematic if you're trying to build iridescent effects. And so I'm going to go over how to build one from scratch. Technically, it's not 100% physically accurate just because we're kind of hacking some nodes together, but it gets the job done. And so I was looking over through the Redshift forums, kind of asking around to see how people were accomplishing this. I knew how to pull this off in Maya using facing ratios, and in Houdini I was trying to figure out a way to do it, and luckily a better Houdini user than me gave me a little hints and kind of helped me out, and so I rebuilt it, and I'm going to show you guys how to do this also. And so basically the idea, let me pull up this graphic. The idea here is you have the RGB spectrums, and so if you just have them both overlapping, you get just black and white, right? And so the idea is that we're going to offset the spectrums a pinch, and so what happens is the further we offset them, the more this rainbow kind of effect starts to happen. And so the idea is, how can we offset the RGBs and control the amount of offset percentage together, all, in a shader system. And so to do this, we actually have to do a little bit of I'm not going to say scripting, but I mean it kind of is. It's super basic referencing. And so we're going to start out our scene using our base look dev scene, and you guys should already know what's in here and stuff. And so if we open up the render view, we'll just have our our default, which is what we've been working with. And so here's our default scene. And so the idea now is we're going to convert this shader to have an iridescent effect. And so let's start by dropping down a Redshift material builder, and we'll call this, or actually no, we'll just use this, and we'll just come in here and adjust this ourselves. So let's just move this out of the way. We'll keep the bump for now. Maybe we'll disable it later if it interferes with our iridescent effect, and we'll keep it gray for now. We'll try a coating, and then we'll explore refractive iridescence and stuff. And so, okay, cool. So first things first, what do we need to do? So what we need to do is we needed to create RGB, and to do that, we'll just bring in some constant, or no, yeah, we'll just use some color, absolute colors. And actually, let's turn on our LUT. So let's get that up. And yeah, so where were we? Okay, so we're gonna need 3 absolute colors. And so we'll just, for reference, we'll do this so that way they're all colored, so we could just easily see RGB, just for layout purposes. And for R, let's drop a 1 here. So now it's red, pure red. Drop a 1 here. Drop a 1 here. And so we've got our RGBs, and we're going to need to combine these together, and then this will guide our diffuse. We'll start with diffuse so we can see what's going on the diffuse before we start putting it all together refractively and stuff. And so what these are basically is R, G, B. 1 is alpha. You want 1 for alpha. These are vectors. Vector being 3 floats together. So what we're going to need to do is we're going to type in vector, and there should be a vector multiply. RS vector mul. And so this is basically multiplying our setups. And so this is basically what we're doing is we're going to multiply this red input, and then we're going to multiply in another multiply. And so we're going to move this over here for now. And the reason actually let's kill this. Actually, we need this to be at the end of everything. So so actually what we need to do before we start combining all the front end is we need to build the back end. So this is going to be input 2 for now, and we're going to start to build what comes behind this first, because I think I need to explain this side before we start putting it all together over here. And so basically what we're going to do is we're going to drop in a Fresnel. And so the Fresnel node is what's going to be controlling the influence relative to the camera angle, since that's what Fresnel does. And we could use different methods of the Fresnel strength and stuff, but what we're going to do is we're going to actually combine the Fresnel influence into a null object, and that's going to be like our controller for everything, because we're basically going to be referencing everything into the null. So and we'll call that the offset control, what controls the offsets of the RGBs. And so now that we've got the Fresnel down, what we need to do is we actually need to drop in another math absolute. So let's actually just duplicate this. And for this, the numbers that we're going to use, there's a paper that explains basically why we need these numbers. Pretty much this number 107, just keep that in mind. We need the number 107. It has something to do with like the way the color moves and stuff, and it's based on some paper. And so pretty much with this now, what we need to do, we'll move it here next to this Fresnel, is now we need to multiply our Fresnel and our math for the red absolute color. So now we'll drop in another, or actually let's just duplicate this one, and let's slice that. And so now let's come in here, connect our input 1 and our input 2, and we'll just call this R. And so now that we've got these two together, we need to put this through cosine. So if you type in cos, you'll get the RS cosine, and this will convert this data. And so plug it in. It's using radians. Just plug it in. You don't really need to do anything else. And so now that we've got that plugged in, we need to add another node, and to convert this info back into color. So we'll type in abs, and we'll get the redshift color absolute. And so with this color absolute, we just plug this back in to convert it back into a color RGB form, because this is data, like math, vector I should say, or not vector, float, a single vector instead of RGB, which is vertex. And so now this plugs into this, and so let's move that down. And so now if we were to build this and plug it in, let's just plug it into diffuse just so you can see what's going on. Oh, forgot to turn on the IPR. We'll get this. And let's actually save our scene. And so what's going on is the Fresnel, based on the IOR, is controlling where this red's falling, basically, based on the index of refraction. See, so we're getting red and black based on the IOR. And so, okay, cool. Now what we need to do for the next step is now we need to build this same setup, but for the green and blue values. And so we could just duplicate this 3 times real quick, and you'll see why we need these later. Let's actually slide all this down so there's a little more room, and let's switch our wiring shape to the better curved ones. I think it's, well, in my opinion, it's better for shading nodes. And where were we? Oh yeah, so now we got to turn this into a G, and for visualization purposes we'll make it green, make this into a blue, make this B, and we need to convert this value now back to 0, back to 0. And what's happening really is it's not the color that's being fed in here, because what's actually controlling the color is this node. So if we were to increase this, we would get that, right? It's this node that's actually giving us our color. But what these nodes are doing is this is controlling our float data that's being converted through these math nodes back into vertex data that we then multiply together with our color, and it'll start to make sense right now. And so what we need to do now is we need to actually drop down a null. And so this null, for color purposes, we'll just make it black. We'll call this our offset null. And so this is going to be the node that actually controls our offsetting between all of the separate nodes. And so let's move this down. Move this down. And so what we need to do now is, and actually we should just kill these Fresnels. We don't need those. We could just do this, because we need to actually have the Fresnel control one node, one Fresnel control all 3 of these. And so now that we've plugged in our Fresnel into input 1 for all of these, and we have our G and our B as 2, this is where some of the magic happens, basically, by referencing our red. And so what you basically need to do is you're going to take your red channel right here, and you're going to copy the parameter. And that parameter that we just copied, you're going to paste it as a relative reference into here. And so we're going to just do that again. And so now these two nodes are referencing this 107 number that we have here. And so now what we need to do is we need to make our offset null control the offset for the G and the B separately. And so our first step would be we need to actually add, let's actually pause that. We need to add parameters to our null. So going up here to the little gear, you can click Edit Parameter Interface, and this will pop up the parameters window. And so what we need to do is type in float, and we'll get this float parameter. So just double click that over, and so this is what's going to be guiding our offset, basically. So now all we have to do is we could just keep everything for now. Just hit apply, and we'll just hit accept for now. So it's at 0. And so this info here, wherever we slide this slider to, is what's going to provide us a multiplier for the offset. And so what we're going to do is now we're going to copy this parameter, and we're going to go into this G, and in here we're going to multiply this, and we're going to paste our relative reference. And so now what's going on is our red node that we have with the number 107 is multiplying against our new offset null parameter. And so, but what we need to do now also is we need to add a +1, and the reason is just because we're going to offset it by 1. And so at the right after the multiply, you need to add a parenthesis just to close this off, because Houdini's expressions are basically using scientific notation, so just keep that in mind. The order of operations matters, PEMDAS. And so at the end of this, we're going to offset by +1, and we're going to close it with another parenthesis and hit enter. And so now what we've got is this value is being multiplied by whatever is in this value +1, just to solidify it as a positive. And the next step is basically we're going to do the same thing now, but instead we're going to multiply by 2 first, and then and build it up from there. So basically we can go in here, and once again we'll just add our multiply, our parenthesis, and oops, YouTube. Paste relative reference, there we go. And now we're going to multiply by 2 and close, but we also want to add by 1 again to keep things in the positive value. And so because we added another parenthesis here, the order operations matters, so we need to add another parenthesis at the beginning after the multiply. So it's multiply and then 2 parentheses, then our relative reference from the node we made, the null, multiplied by 2 plus 1. And so now if we click on this, we'll notice it's 111 plus 74. So if we let's slide this somewhere. Let's just move it that way, and we come back to that. You'll notice it's now 121.66. And so the idea is that sliding this controls the offsets for this and this. And so and if you need to see the exact numbers that are being offset, you can just click here or just leave the expression. And so okay, now cool. Now what do we need to do? So we need to now connect our color back in to this float data. So we'll just expand this a little. So let's make another, or let's just duplicate this. Let's cut it. And let's duplicate it again. And so what we're going to do is our input 2, input 2, input 1, input 1, and let's just organize these a little better. Just for the sake of organization. And let's move this up. Highlight all this. Slide it up a bit. And okay, cool. So now we need to combine the R, G, and B together. And so for that, we could just use an add. And once again, you'll use a redshift vector add because these are RGB values. And so all you got to do now is literally plug in. Let's plug this in here. Plug this in here. Let's make another add, vector add, and this will plug into this, and let's just move it down. And so then this output now goes into there. And so what we'll end up with now, if we refresh our render, is in theory we should end up with a gradient of several colors. So let's see. Yeah. And so this is what we get right here. And so right now it's plugged into the diffuse. And so the idea, now that we've got all this set up, is you could control the Fresnel and the offset together, which will manipulate stuff. And actually, to make things a little easier, we should just copy our IOR value. So let's just copy this parameter, and let's make a new float, and we'll just label this IOR apply, and we'll just relabel this to offset. And actually we probably have to fix our calculation in here. Offset. Oh no, yeah, it should still be right. Let's actually reload. Huh, strange. That's a little weird. Why? Oh, because it's at 0. That's why. Okay. And so now what we want to do is we're going to copy this parameter and we're going to just paste it into here as a relative reference. And that way we could just control both the Fresnel and the offset amount. And so as you can see already, just by doing this, we're getting a whole bunch of crazy rainbowy looking kind of effects, and so that are relative to the camera that we're facing. And so the idea is that you could pretty much tweak these parameters further, you know, using extinction. As a matter of fact, let's add the extinction also, so we could just control everything from one node. So let's add another float, call it extinction, and apply this, and we'll copy the parameter, paste it into the extinction coefficient as a relative reference, and cool. Now we can control the extinction, the IOR, and the offset, you know. And so just look at all the crazy variations I got just in a couple seconds sliding that around. And so then pretty much this, we'll just slide this over. This is our controllers. You can think of it that way. Our shader setup. And so we could just leave these alone now. We don't even have to touch these parameters. And this is just our iridescent setup. And we could just move this away or whatever, right? And then we could have all this as a totally separate thing. So then we could have our bump and whatever else we want. And then we could have our controller, our offset null, and we'll just leave that here next to this node. We'll just make this into a blue. Make this into a, I don't know, I think black's fine. We'll just change the shape or something. Oh, we can't. That's right. Let's just do... yeah, yellow. And so now what we know we can do, which is cool, is using this, now we can get pretty creative. So if we just plug back in our diffuse color like we had originally, and this time we adjust our coding. So now if we plug this back in to our coding color, what we'll get is we'll start to get this iridescent effect. And so if we adjust the coding strength, the weight, whatever, right, is just a ton of things you can do right here, and just adjust that, or you could even plug it into the specular color, so reflection color, and now we're getting it on the edges and stuff too. And so what's neat is we can adjust the base color, you know, a nice dark color or something. Or if you want, you know, you could just turn on refraction and go to town. You know, now we've got like a frosted iridescent plastic or glass. You could turn on dispersion and get even more of those colors inside. We could kill the bump so we get a smooth material. Then adjust the roughness so it's nice and glossy. Now we've got some crazy IOR going on. That might be way too strong on the dispersion. But, you know, we're just playing around with stuff. Let's try 50. Maybe 1.3 on the IOR. And yeah, I think you guys kind of get what's going on here. So we're, you know, building pretty much an iridescent material. And, you know, it didn't take too long. It's not too complicated. I mean, it's not like we wrote any code or anything. We just, you know, multiplied and added stuff together, and we just copy pasted relative references. And the cool thing is, now we've built this, we could basically, you know, save this out as a, if we were to back out, right click this, save it out as a digital asset, and then we could just import it into new scenes that might need this kind of effect. Let's bring in the bump again, just for fun. Might be a little too strong, so let's drop that down to 0.1. And let's actually move the camera around a little. Oops. Lock the camera. Cool. And yeah, I mean, now we've got these kind of iridescent effects, and we could, of course, tweak this further, move sliders around, and just go to town on it. And you can just see just endless possibilities. And so let's actually try a little bit of a bucket render. Let's make this 250% larger, and let's just do a bucket render and see what we get. It's probably going to be a little noisy because we're using the IPR ROP. but that's okay. We're just previewing stuff. And so if we zoom in here, yeah, we've got all these banding colors and variations, and then you could see it even in the bump subtle spots and stuff. You got it down here. It just looks cool. And again, the idea is that you could do this on non-refractive objects also. We could have just as easily turn off our refraction back down to 0 and have the object just be a dark color. It's like this black. And you've got, again, these iridescent effects, kind of like a beetle's back or something, the shell. And so pretty much, well, this opens up a lot of doors for a lot of cool possibilities and stuff that you guys can explore and mess around with. Now, so just imagine this plus all the other layering of triplanar scratches, and just combine this with what we just saw in the other tutorial. And basically it opens up a lot of doors for you to have fun and make some cool funky shaders that are pretty exotic. And so I think I'll just go back to making this refractive, and we'll render this out with the well, actually, let's save this, pause this. We'll render this out with the final render ROP just to see, and we'll do 150%, and let's change our camera from render cam. We'll just use the IPR cam. And actually, no, yeah, let's keep this at 250. And let's knock out a render just to see what we get. And again, this is probably going to render a little slow just because refraction and dispersion, stuff like that's a little heavy to compute. As you can see, there's little fireflies and stuff. So, or actually, I didn't even change to the render ROP. So let's do that. And so, being that it's a pretty heavy effect, it might take a little while to render. But I mean, compared to other render engines, Redshif's still crazy fast, so it doesn't really matter. So if we come in here and check out some of the specular stuff like that, just to see kind of what's going on, getting some cool little specular. Got a whole bunch of refraction everywhere, with all these changes in hue shifts. We've got a reflection here, nice little hue shifts. And so, yeah, I mean, pretty much we were able to quickly bang together a pretty interesting and neat asset with refraction and dispersion and a little subtle iridescence. And so, if we were to change the HDR or change our viewing angle, let's go back to our IPR ROP. Let's go to 100. If we were to let's just change the HDR just to see what, what we get. And we'll try out try this. And it's pretty cool, we've got, can rotate the light around. Let's actually pause this, bend that, kill the bending so we can get some light maybe instead of the shadow. Yeah, we could rotate around, get some pretty cool looking stuff. Obviously, if you wanted to go crazy, you could make caustics and stuff. And yeah, why not? Let's throw some caustics into this just for fun. Let's move around. Our light's coming from over here. Let's hit Control and click on RS light. Move it this way. Right now it's ridiculously strong, and we're going to use a spotlight just because spotlights are really good for concentrating caustics. And we'll have this emit caustics. Let's emit 300,000. And let's have our object receive caustics. So if we click on our shader ball and we turn on, okay, it's got casts and receives on. Let's make sure our floor does too. Visibility. Well, no, it wouldn't be casting, but it needs to receive. Visible. Okay. That should work. Let's dive over to our ROP. Oh, oops. I'm supposed to pick the ROP. Pick the ROP. And let's go under Redshift. Let's global illumination. Photon mapping. Let's enable caustics. And for maximum number of caustics, let's try 200,000. No, well, let's just try 500,000 for now and see what we get. And let's save our scene. And let's actually make sure our spotlight, where's it at? Down here. Let's turn on bucket mode, because caustics only work in bucket mode. Hopefully they introduce soft caustics so we can see them in IPR. And yeah, cool, we've got some caustics down here now. Neat. let's increase the intensity. Even though technically this is breaking what's considered physically accurate, who cares? Let's just let's just do it to do it, because caustics look cool. So we've got a little change down here. This is going to brighten up quite a bit. Let's try 500,000. Cool. Maybe let's move our camera just a pinch so we could see a little more of the caustics going on. Now we can tell it's a little too strong. So let's bring this back to maybe 1.25. Even though I kind of like this rainbow banding we got going on. Let's try 2. Let's just go all the way. Exaggerate. That's the beauty of being a biased engine. We could break the rules. So let's break them. Why not? You know. Yeah, I like this. This is cool. So let's actually make a final render of this. And so I believe this cam has caustics turned on, but let me make sure. Photon mapping, enable caustics. It did not. So let's make this 1,000,000, and let's use 0.2 for the search radius. And let's make sure our camera is the IPR cam. Okay, cool. Let's pause that. Let's do 150x. Let's drop a render with the render ROP and see what our results look like. They're probably the samples are probably too low, to be honest, for something as refractive and glossy as this, but let's see. Well, it's not bad. Let's actually try 250. I believe. Yeah, that's pretty good. Good size. Resolution. Let's zoom in here. It's not too noisy. It's not perfect either, but that's okay. I don't want to bore you guys with trying to get a clean render. I'll make one and just include it in the files just because. And actually, I'm sure if we look at the specular's not bad. Refraction's okay. The dispersion's probably a little too strong, but that's alright. Reflection isn't too bad either. It's bearable. Cool. Let's check out this caustic. Little too strong. Let's drop down the search radius and let's actually get to our light, I mean, and let's drop this down to 1.25 or maybe 1.5. 1.6. It's just pretty amazing how fast the caustic pass gets calculated. They're not ultra sharp. I don't have them on to be ultra sharp right now, but regardless, it still looks good. Could maybe increase the light intensity itself. Maybe use a warmer light, so let's switch to temperature. Let's try 4500 and an intensity of 300 just to see what we get. Warmed up our scene. This might be too warm, but let's just see what the influences of the caustics. I just kind of want to know what it's doing there. Oh yeah, the caustics are much more intense from the looks of it down here already. We've got some strong rainbow colors. Oh yeah, totally. It's cool as hell. So let's switch our color to white and drop our intensity down to 1. And let's just emit 1 million. 1 million caustics, just go all the way. Photons, I mean. And let's save this in case Redshift isn't happy and we get a crash. Let's just see what happens. So far so good. Not bad. Caustics are just a little bit less intense. I kind of like that warm hue. So let's bring temperature back in, but let's do 5200, which is considered a pretty normal type of day, but not too sunset-y, golden hour, so we keep some of the cool. Let's try 5,000. We could try 48 also. Oh, oops, not 40, 48. 4,800. Yeah, I think this is fun. Okay, now let's just go into our render op. And why is this 5? Huh. Okay, this is a mistake. This is supposed to just be. This should just be 3, and this should be what's 512. And actually, I need to check the base file. I hope that I didn't accidentally switch that before I give it to you guys, because that was wrong. And I'll be sure to fix that before I put it in a zip file for everybody. Cool. This looks neat. Could maybe adjust the exposure a bit. Yeah, and so now we've got a cool little iridescent shader. It's got a little bit of bump roughness on it, some dispersion, a little bit of caustics, just because why not. And yeah, hopefully that's it. I'll render up a nice, well, this one's not bad, but I'll render a cleaner one just because. And hopefully you guys learn now how to apply the techniques here. So we'll just make this iridescent. And now you guys know that basically all I got to do is set this up correctly and have that referenced from the parameters in our null, and you could just go to town, tweak it all you want, and lay it on top of your material, either as a coating layer, a specular layer, a diffuse layer, whatever. You know, I mean, technically, iridescence is a coating layer effect. It's something that happens on a thin film on objects, so I would only keep it on coating, maybe specular if you want a little more intensity to it. But besides that, you shouldn't really need to do it on the diffuse. The diffuse color should just be its own thing, and then your coating will influence it. But okay, cool. So hope you guys enjoyed this bonus tutorial, and thanks again for supporting my Patreon, and I look forward to working on another tutorial for you guys. Thanks.